Hi roboticist. Today we're going to learn another method to make a pick and place application. I know that we have already discussed about this topic in another video. I'm gonna put the link in the top right corner, but I have seen that some of you had some problems in replicating with their robots. And so I decided to show you another method which in my opinion is more straightforward, and we're going to use the move group interface for gripper as well, and you're going to figure it out what I'm telling you in the upcoming minutes. So before to start, make sure to subscribe to the channel if you like this kind of video, and if you want to become a robotic software engineer, don't forget to check my course. As for the moment, I have done only the course for beginner, which I will say that is the first step to start to make some practice with this kind of application, where you are going to make your hand dirty in the robotics application in the real world, or better, in the industrial world. Okay, so that's all for this introduction, and let's jump directly to the topic of today. Okay, so what we have done in the last video where we dealt with pick and place is to create this pick and place application, where basically what we had is composed by the main section. We add a collision object, and then we call this function pick and place, which are described here. And then in each pick and place function we are calling the open gripper, so and the close gripper. The key point to bear in mind is that with this method we are going to make an extensive use of this MoveIt message called grasp, which has a very good structure in my opinion, because it has already built in some function like grasp, pause, pre-grasp approach, and so on and so forth. I already discussed about this topic in the last video, so I don't want to make it again. Before to start another method, well, just see, let's see what is going on in the simulation with MoveIt. We can open the demo launch file of the Cobot MoveIt configuration package. So ROS launch Cobot MoveIt configuration. Okay, this file is automatically generated when you are creating a MoveIt setup assistant. We already done this video, but okay, this here there is our robots, and then we are gonna run the pick and place application that I have just shown you. So ROS run, I have built this code in this package here. Don't worry about that, I'm gonna provide the link in the description down below for my GitHub repository. And so this is gonna be pick and place node. Okay, let's see what's happened. So here you can see that you have our collision object, which is composed by the table to pick, table to place, and the object where is picked. And then is placed in this position. Okay, you can see that if you use the grasp MoveIt message, the pick and place is very structured. So you're gonna have the pre-pose, the approaching, and then when is placed, you have the function to release, and so it goes in, for example, in this direction once that is released. Okay, so this is an introduction of what we have already created. And what we're gonna do now is to create another C++ code step by step. So let's create this one and call it pick and place simple.cpp. Okay, I think that is better to have this as a reference. Okay, so let's start. Well, first of all, this we can just copy and paste. Nothing new. Then, for a good structure, let's go directly to the main. Okay, so let's create the main section. Okay, so here we can copy and paste. So we can copy and paste also this one. And the main difference here is that what we're going to do, we're going to create another move group interface object that commands the hands, or better the gripper, that I remember you that is composed by the two the gripper right and the gripper left. So I'm gonna copy and paste. I'm gonna create so another object, and I'm gonna call it gripper, and this is referred to the hand. This is the name of the group MoveIt interface that we have set up in our MoveIt setup assistant. Okay, so now what we are gonna do is to just create a pre-grasp pick position. So pre-pick position, and we are gonna pass into it the move group interface group. Then we will wait 1 second. Then what we're gonna do, we are gonna call the pick function row. Then let's wait another seconds, and then what we will need to do is to close the gripper, and this time we are gonna pass inside this function the object move group interface that we have created gripper. And then let's wait again. Then once that the object will be picked, so the gripper are closed, we just need to bring our end effector to the place position. So we're gonna call another function which is place. Of course, we are going to create all these function here in a moment. Then let's wait another seconds, and then finally, once that the end effector has reached this position, let's open the gripper. And of course, we need to pass the move group interface object called gripper that is referred to the group hands. Okay, and then just wait for shutdown. Okay, this is the structure of the main function, and what we need to do now is to create this function, the pre-pick, the pick, close gripper, place, and open gripper. So basically, we each function is a representative of the position of where the end effector needs to achieve. So let's start with the pre-pick position. So the function will be void pre-pick. Then the object that we will need to pass is has the structure of this object. So it's gonna be this one, and then we are going to call it move group. What we need to do is to create a geometry message pose object. And we are gonna call it pick position, or better, pre-pick position. Then we are need to set up the orientation of the end effector, and we're gonna use the quaternions object. Now we're gonna set up the angle in terms of row, pitch, yaw, and set up the orientation. Here we are. Now we have set up the orientation. We need to set up the position. Very easy. So it's gonna be pre-pick position dot position, where in x, y, and z. So the position will be x1, Then I remember you that position will be y0, but let's give it some clearance. Okay, and then the height will be always the same, 0.5. Then we need to set the post target, so move group, and we need to pass the pre-pick position. And finally, before to finish this function, we need to ask the object to move. Okay, that's all. So if we follow the main, we need to create the pick, which basically it will be very similar to the pre-pick. At least it has the same structure. So we can just copy and paste. But now we're gonna call pick. And let's change the position also. Okay, so now that the robot will be in position, is ready to close the gripper and grasp the object. So we need to create the close gripper function. Again, here it has the same structure. Let's call this object move gripper. And this will be very easy because we just need to call the function, or better the method set joint value target. So move gripper, set joint value target. And then if you have IntelliSense, you have different, or better, ROS snippets in the extension of your Visual Studio Code. You have a different way to call this, to give an input to this method. We are going to use this one. So we will need to have the string as the name of the joint, which is gonna be a gripper right joint, and then the value. So let's do it. And then the value for closing, I remember that is gonna be 0.55. Okay, and then we just need to ask to move. Okay, then since that we are here, we can create our open gripper. This will be the same, with the exception that we need to adjust the value. I remember you that I'm going to control only the gripper right joint because it's a mimic gripper. So the gripper left joint will move accordingly as a mirror. Okay, so let's come back to the main, and there's the place function to create. But here it will be very similar to the pick. We just need to change the orientation value in row, pitch and yaw angle, and of course the position. So this will be the place. Then this will be move group place. Then let's just change this object, and let's call it place position. Then the orientation here will be this one. Feel free to practice with the row, pitch and yaw. So the place position will be on y0, on x0, y1, and let's release slightly upwards for the moment. So, and then we just need to call the move function belonging to the move group interface class. Okay, I think that is everything. Just give it a try. So first we will need to build the package and update the CMake list. Nothing new. I'm gonna do it now. Okay, let's see what is going on with the Rviz. Let's run the application. Okay, okay, we have not created the collision object. We are gonna do in a moment, but as you can see, this is the pre-peak position where the end effector is going to reach, and then it's done. He will go to the peak position. Done, and then he will close the gripper. Done, and then he will go to the place position that will be somewhere here. And once the position of place will be reached, the gripper will open. Here we go. The gripper has been opened and the application has been completed successfully. Okay, so to avoid any collision with the real world, let's create our collision object, so we are sure that the robot will not collide the peak table and the place table, so the planning will be done accordingly. Okay. Okay, here we are. So in this case, we don't need to have the object because, of course, it will need to collide with the object that needs to be picked. Uh, okay, let's build the package and test it again. Okay, now you can see that the table of picking and the table of placing now is correctly show up in the Rviz. Let's see the behavior, and it should not change. Okay, the place position is reached correctly, and we don't have any collision here, as you can see, and the gripper release accordingly. And now we can test in the real world. So how to do that? We can test in Gazebo. So what we can do now is to test this application in a simulated environment in Gazebo, where we pass the robot URDF file, the world, we are spawned our controller in the real world, and we have already done this launch file when we have interfaced MoveIt with Gazebo. So at the moment, nothing new. Okay, we have Gazebo that is running parallel with MoveIt plugin in Rviz. So now what we need to do is to run our pick and place application with a simple method, what we have just coded. Okay, the robot is approaching to the pre-picking position. I remember you that for all the joint we are gonna have position controller, follow joint trajectory controller, and for the gripper we are gonna have effort controller, follow joint trajectory controller. So the end effector has reached the pre-picking position, then is going to grasp the object, then the gripper is closing, the object is correctly picked, and we have used the grasp fix plugin for Gazebo. We have done another video for that, and now you can see that the robot is going to the place position with the object attached to the gripper as we want. Okay, you can see that the robot is approaching the place position in the position where we have set up in the pick and place code. Okay, it's reached, and now the gripper are opened correctly and the application has finished. Okay, that's all for today. I hope that you enjoyed this video. I hope that this content will be useful for you and solve some issue that you might faced using the MoveIt message grasp class. Don't worry, I'm going to provide all the code in another repository that I will create for this video, and I'm going to provide the link in the description down below. If this video added value to your robotics software journey, let me know in the comment down below, and make sure to subscribe to the channel and hit the notification bell. And see you in the next video, and as always, keep learning robotics with Ross.